Okay, so this session is about applying Kirchhoff's current laws to perform circuit analysis and to solve for all the currents in a circuit. You will immediately notice here that this is not a real circuit. It represents a circuit, and the boxes A, B, C, D, E, F, G, and H are representative of circuit components. They could be a current source, a voltage source, a resistor, a capacitor, an inductor. I'm also identifying a ground in the circuit, which we will not use, but just I want you to be used to setting a reference node on your circuit. But in general, when we think about Kirchhoff's current law, it is very important to realize right from the beginning that the application of this law does not depend on the components in each branch of your circuit. What Kirchhoff's current law expresses is conservation of charge, and what it says is that the sum of all the currents going into a node is equal to 0. And so what we will learn today is how to use that law to solve for all the currents in your circuit, as long as you know other currents in your circuit. So first you have to observe the circuit, and then identify and label the nodes that you're going to use to write the KCL. So you have to identify all of the nodes in the circuit. If you're a novice, you might identify the nodes as A, B, C, D, E, F, G, H, and I. But if you observe your circuit a little more closely, you will node A, in fact, is this whole section of line here. There are no components in this line that would cause a voltage drop, and so your node A is that whole left-hand side of the line. The same thing happens with node C. You see that's a solid line, no resistance, no voltage drop across the line, so that is node C. So now we're ready to begin. The other thing that you have to do is draw your circuit, your currents in the circuit, in each branch of your circuit. And you will notice here that when I draw the current, I draw an arrow. And the arrow is pointing in the direction that I'm assuming the current is flowing. And so the convention that I'm going to use, because in general I don't know in which direction the currents are flowing, is that I'm going to draw horizontal arrows from left to right and vertical arrows from top to bottom. And so again, this is the direction I assume the current is flowing. I don't know that the current is flowing in that direction. The other thing I have to do is I have to name the. So I will name the current that is flowing from node A to node B, IAB. And you'll notice that the notation not only gives me the relationship where the current is flowing, but it also tells me in which direction it is flowing. It's flowing from A to B. If I wanted the current flowing from B to A, I would have named it IBA. Then I have IBC from B to C, IAE, the current flowing from A to E, IEC, IAH, IEH, and IHC, and then last but not least, IBE. Now I have given the values. What I'm giving you for this problem and for the subsequent problems that you will be solving on your own is IAB is 2 amps, so I'm giving you IAB, IBC, IAE, and IEH. So let's just take the time to investigate a little bit if this is enough for you to solve for the rest of the currents in your circuit. If you have IAB and IBC, then the only other current coming out of node B is IBE. So in fact, these two currents, between the two of them, they will allow you to calculate IBE. So now you have IBE. Okay, I have IAE, IBE, IBC. If I have and I also have, let's not forget, IAB. So IAB is the current that's going up through here and through this branch. So I have IAB and IAE. That will allow me to calculate IAH. So now I also have IAH. I have IAH, IEH, so that allows me to calculate IHC. And then now I have IBC because, again, this is coming into node C. It's flowing out of node B and flowing into node C. I have IHC that's coming up in this direction, also flowing into node C, so that's going to allow me to calculate IEC. So it looks like I have enough currents to calculate all the currents in my circuit. Okay, but I still need to be methodical. I still need to solve my my circuit. I have to write down all KCL equations. So node A is here. IAB is coming out of the node. IAE is coming out of the node. IAH is coming out of the node. So I subtract. Minus IAB minus IAE minus IAH is equal to 0. For node B, IAB is going into the node, IBC is coming out, IBE is coming out. So how do I write this? IAB minus IBC minus IBE is equal to 0. In the same manner, I have IBC now is coming into the node C, IEC is coming into the node, IHC is coming into the node, and so I have IBC plus IEC plus IHC. Node E, if you notice, has 4 currents. 2 of them are coming in, 2 of them are going out, so I write the equation accordingly. Okay, so I have all of my equations. I have 5 nodes, 5 equations. Now I have the values of the currents here. So what I do is I replace these values in all the equations in which they appear. Okay, so I take the time to observe the equations. What do I have here? I have 2 minus minus 5, so that's 2 plus 5 is 3. 3 minus IAH is equal to 0, so IAH is equal to 3 amps. I have 2 minus 3 is minus 1, and so this would be minus 1 minus IBE is equal to 0, so IBE is minus 1 amp. Okay. IAH now occurs here, so I'm going to say this is 3 amps. 3 amps plus 4 amps is 7 amps, so this is 7 amps. Because minus IH plus 7 amps is equal to 0. So now I have, minus IHC. IHC occurs here, so this would be 7 amps. And it doesn't occur anywhere else, but now I can solve. I have IBE here is minus 1 amp. So if you notice, I have node C and node E. The only unknown is IEC. And this is actually, you'll see, so you would expect that both equations will give you the same value for IEC, and this is a way to check your work. If I look at the equation from node C, 3 plus 7 is 10, so IEC is minus 10 amps. Let's see if I get the same thing from the equation in node E. Minus 5 minus 1 is equal to minus 6. Minus 4 is equal to minus 10. Minus 10 minus IEC is equal to 0, so IEC is equal to minus 10 amps. So what does this tell you? What this tells you is that even though you have 5 nodes, those 5 nodes are going to give you 5 KCL equations. Only 4 of them are independent. You might think the 5th is superfluous, but if you do take the time to solve for the 5th or to work it out, then what that gives you is a way to check your answer. Because if you had found an answer from the node E equation that was not consistent in IEC with the answer from node C, that would have been an indication that you had done something wrong, or maybe that I had done something wrong. Things that might happen if I underdetermine your set of equations. In other words, if I give you too few current values, then that means that you're going to end up with more unknowns that you can solve for. But in fact, the opposite is also true. If I give you too many values of current, then you're going to end up with inconsistent calculations between your current values, And that could be one source of error. More usual than that is that you might have made a mistake somewhere with your signs. For example, if you had done minus and forgotten that this is -5, and so that this ends up being +5 overall. So check your work, practice a lot, make sure you don't make math errors, and these problems should be fairly straightforward.